So we've been in the biomass to energy business for some decades now, and we found that producing energy out of biomass, either thermal energy or power, can generate other opportunities of business around this primary activity. And this project we're going to explain today is based on that concept. Okay, the project has been elected under the LIFE program in the European Union with the name of CO2 Integration Bio. And we have an industrial partner in this project, which is part of the Air Product group, and has been supported by the regional government in the Castilla-León region, which is where the project is located. A little bit about our company. We are a fully integrated biomass to energy operator. What that means, well, in our case, is that we are project developers. We don't hesitate to approach greenfield projects. We structure financing of that kind of investment. We have our own thermal engineering firm, and we do have our own boiler technology. Not yet able to supply the services that the previous speaker need to reconvert that boiler, but almost there. Maybe the next project we can compete with Valmet, I don't know. But we are usually working at a smaller scale, around 20 megawatt. We do have some other experience, larger scale, around 50 megawatt electric. So we are a technology supplier too. Then we do operate and maintenance biomass to energy assets. We do that in different countries these days: Spain, Portugal, US. And something that probably is a little bit specific in our company, that we do provide biomass to most of the plants we develop. So we do manage forests, and we do manage agricultural residues to produce the fuel we use in some of our plants. So it's not clapping hands, I think. It's okay. All right, continue. So the project we'll explain is based around this plant. This is a 15 megawatt electric plant, initially designed to produce gas power, so full condensing system, and it is located north in the north half Spain, like 250 kilometers north of Madrid. So this is how initially the project was designed. We had our own woody-based biomass supply structure, and a biomass boiler of our own design. And as I said before, we produce 58 tons of steam, and we fully condense the steam to produce power, 100% power. And we export that power to the grid. That's how this project was initially conceived, and financed, and then built. And we take obviously 100% of the gases, and once are filtered and fulfilling the environmental limits, going back to the atmosphere. And then we have a production of 1 ton per hour ashes that most of it, as of today, are going to landfill. Then we reached an agreement with a company that was looking for location for the largest greenhouse to produce roses in Europe. This is a 14-hectare greenhouse, and they need a lot of power for lighting, and they have a big demand for heating, and initially those demands of power and heat were supplied by the grid, the power demand, from 1 to 14 megawatts. and the heating needs coming from the use of natural gas combustion in their own boilers, and the CO2 they need as an important input to grow the roses. They were producing part of it by the combustion of the natural gas, and when they don't need the heat, they buy the CO2 in the form of liquid CO2. So they have three major inputs: power, heat, and CO2. So we have this separated process structure till today. It has a higher CO2 footprint, it has a lower integration, and in the side of the biomass plant, we were supposed to be using an homogeneous fuel based on woody biomass. Then we were pushed by a change of regulation that, I mean, it was very hard at the beginning, but I think that today we even thank the regulator for changing the rules of the game once we have the plant up and running, because it forced us to scratch our heads and look for the best way to optimize the integration with our neighbor. So we came up with an integrated solution that we are going to explain to right now. But I wanted to show this picture where you can see that the integration is a lot of fun for engineers. I think it's a very innovative concepts applied here, at least how we integrate all of that. But behind the scenes, circular economy implies complex contractual structures. It's not simple to connect all the energy flows and material flows in the long term and make it work in a balanced way. So this is, if you want, the PID of the contractual structure of this project, which has been, I mean, a big effort and took a lot of time to put it in place, playing the, I mean, with different companies playing different roles here, from the operator to the CO2 supply, the thermal supply, power supply, and so on. So the first step of this project has been design a CO2 plant. So we are capturing around a little bit more than 50% of the CO2 of the flue gases of our biomass boiler. We're cleaning those gases, and then we produce CO2. This CO2 has two applications. First one is to feed the needs of the greenhouse, and the second one it's for the food industry. So this is, as far as we know, the first food quality CO2 production based on renewable CO2 origin. So this, as you can see here, we try to represent the CO2 plant will be inside the boundaries of the biomass plant. We will provide in their thermal needs and the power needs out of the plant, so it's 100% renewable energy, and at the same time they are capturing, or we are capturing through in the CO2 plant, as I said, 50% of the CO2 emissions to the atmosphere. So we are having a negative balance in terms of CO2 here, and again we are going to produce the first, as we call it, green bubble for for the food industry, breweries and soda drinks and so on. They will be using this green bubble, and then, because the needs of a higher amount of fuel, we have to push the technology we use in this plant, and we did several modifications, basically in the boiler, but in the gas control system too. And now we're using a wide range of fuel, from olive cake, which is a byproduct of the olive oil industry, to vineyard residues and gardening residues, all that mixed and treated. This is the fuel we're using today, and including the green residues of the greenhouse, of the roasters greenhouse. So we are being able to manage all this variety of fuels, feeding the boiler, and said before, providing heat and power to the CO2 plant. And the last stage of the project is actually connecting with a direct power line to the greenhouse, and with a it's 100 meters insulated piping system. We are going to provide the heating to the greenhouse. So this really big greenhouse, I mean, now they have 14 hectares, and they have a project to increase their production to 21 hectares. Again, it's the largest rose producer in Europe. They will become neutral CO2, completely neutral CO2. All the power demand and the heat demand and their CO2 demand will come from renewable sources. So this is almost the final picture of this project, but we still have here an output of the project, which is ashes going to the landfill. We have been working for the last 3 years in a project to develop our own organic fertilizer based on the use of these ashes. We already complete the development of this product, and we already conducted field trials. So we have tested the product, and now we are launching, we are launching the last part of this circular economy project, where by using, it's not very glamorous raw material, it's chicken litter and post-compost mushroom. We are now again launching the production facility for the fertilizer. So we will have here what we see as a real zero residues activity, with complete optimized use of the different kind of biomass we are incorporating to our biomass plant. So it's been a really interesting experience for the last 4 years since we start this project. We are now finalizing the permitting. Next year will be construction phase, and 2021 is the startup for the complete system in the different phases I've tried to explain. So we're really excited about implementing all these different concepts in one single location. And now we are trying to export this experience to other plants that we are operating in different markets. So what we learned of this experience applying the concept of circular economy is first that we have technological barriers, so we need to innovate at technology level to be able to implement this kind of projects. Sometimes regulatory barriers, because circular economy, it's a great concept, but when we go down to the ground and try to implement, sometimes regulation is not yet ready, and it's a little bit messy to get all the permits in place for this integrated process system. Commercially, it's sometimes you have to change the idea of supplier and customer, and then you have to think more in a partnership approach, even if you're selling some product to another company, but at the end you're holding hands for the long period of time, and there is this interdependence that you're building here. So changing that idea, I think it's one of the barriers that we have to overcome sometimes. And nothing to say about the legal nightmare of putting all this in black and white papering and in a legal way. Innovation coming out of this project, optimization, nothing to say, but a better use of all the inputs and the infrastructures implies, and definitely a net reduction of CO2 emissions to the atmosphere. And for us, it's important that we are here in some way consolidating some ideas that we have been putting partially in place in different projects in one single location, where we can see that if you have a biomass to energy facility, you can do more things around it. I mean, it's you always have some waste heat. You have some extra capacity you can use. And usually you have a 24/7 facility that enables you to facilitate other activities linked to it. So this is what I wanted to explain about the project. Any questions?
Thank you very much for the presentation. You'll also be joining our panel later on, right?
Yeah.
So we'll have opportunity to speak there, and you're available, of course, for questions. But any immediate questions? Right here, the microphone, where did it end up? Oh, there it is.
Thank you for your presentation. My name is Ishraq. I'm from Mazen, Morocco. My question is about the ashes. You mentioned in the last part of your presentation that you worked on a project of fertilizers.
Yeah.
I want to know if you managed to first sell them to farmers, because in some countries farmers do not like them, so nobody buys them. And second, have you thought about other opportunities to use those ashes, like sell them to cemeteries or other opportunities? Thank you.
Well, we think a lot about what to do with the ashes, because 15 years ago it was right to sell the ashes to companies producing standard fertilizers, and that was the way to dispose the ashes during years. Then European regulation changed and name it that kind of ashes a residue. So we were not allowed to do that. Now we have to go through this channel of producing our own fertilizer. There is a market for that. Actually, local market is willing to take much more than we can produce. That's in a 50-kilometer radius. We are in the middle of an agriculture area, actually. And before we reach to this solution, we've tried other venues. Actually, we have produced our own cement, our own concrete, based on ashes. We've paved a big part of the wood yard using our ashes. And yes, we are partially selling some of the ashes to cement plants. But logistics are penalizing because they are too far. So for us, the best solution is this organic fertilizer.
Hello, once again, Marek Pinkas from Poland. I have quite a tricky questions, perhaps not directed to you, but the question concerning, once again, environmental impact of biomass burning instead of coal, for example, because I read some articles that in reality the very modern burning of coal is cleaner than that burning of biomass in terms of, for example, dioxin, or in terms of dust, because but this perhaps I am not right. And second thing is that in Poland, I don't know what is in your area, but in Poland there are some unfair behavior that some companies are cutting trees to produce pellets to sell it as biomass, which is later burned. So that in some cases this is just destroying forest to pretend that this is a biomass. Did you meet something like that? Did you meet something like that? And I just would like to hear a comment about that.
It happens that we do have experience in coal combustion too, as a technology supplier. So in terms of emissions, you mentioned dioxins. When you use virgin biomass, like this is the case, you don't have that level of that kind of emissions. definitely much lower than in any coal combustion systems, even the most advanced ones. That's, I mean, we can later go into more detail if you want. Nothing to say about the CO2 footprint. I mean, what we do in the biomass to energy process is we take the energy of the carbon connection in the molecules, use it, and bring it back. So there is no CO2 addition to the biosphere. That's the basic concept for the balance of the biomass to energy processes. And when the tricky question about cutting trees and making pellets and use it to produce energy, I mean that what is tricky is cutting trees. How you do it. I mean, unfortunately, when we talk about forest preservation, sustainability of forests, especially in developed areas as Europe, there is no such a thing as a virgin forest. So all the forest has been affected by human activity, one way or another. Now it's our responsibility, because we know how we can affect the forest. So it's our responsibility to preserve the forest. Believe it or not, Spain is one of the countries that for the last 50 years has planted more trees. Plantations need management, and management is not it's not looking at the trees and clapping hands. I mean, you go and you cut whatever is needed to keep the forest healthy and maintain the forest, forever. If you do it right, you're helping the forest, and you can take the biomass that is left to produce energy. That's the right way. If you don't manage the forest property, yeah, maybe you are damaging. But it's not because you use it to produce biomass or energy. It's because you are cutting the wrong tree. So it is not a sustainable management system. And that is something that, we have to watch, definitely.
So thanks again.
Sorry for the long answer.
Quick question, or shall we do it later?
You're next anyway, right?
I am.
So it's go ahead.
I'm delaying myself. Okay, so I can see that your sort of circular economy makes total sense when you're looking at it from the outside, but does it make sense financially for the participants?
Very good question. The investment in the CO2 capture and cleaning plant is not made by our company. It's as I mentioned before, it's an industrial gas production company. So that is a financially profitable investment by itself, because in terms of cost of energy, they are cutting their cost of energy, and at the same time, it is true that they have a marketing benefit, because their client in the food industry, they really appreciate that the green energy of the product that they are producing there. Same thing for the greenhouse. The greenhouse, they are saving between 0.75 and 1 million per year in their energy bill with this heating and power connection.
So there's a business case as well.
Yeah.
Great. So thanks again, and you'll be joining the panel for more of this. Thank you.